are continuing our lessons on trig. We have 3 more lessons. We're going to take them over 4 days though. One of them will take a couple days on. So that'll take us through the rest of this week with trig. So far with our studies of trig, we have been using our calculator, and the calculator has been very necessary for what we've been doing. Either solving for angles or sides of right triangles, or then using our law of sines and law of cosines to solve for angles and sides in non-right triangles. The calculator was very necessary. In our lessons this week, the calculator will not be used. So these lessons are going to be looking at some special trig angles that can be evaluated without the calculator. It means not today in today's lesson yet, but starting in with what we're going to talk about tomorrow and the rest of the week. Remembering some special triangles that you learned in Chapter 8 will be extremely important. So in Chapter 8, we learned a 30, 60, 90 pattern and a 45, 45, 90 pattern. And those will be very, very, very necessary to know for the lessons starting tomorrow and through the rest of the week. If you don't remember those, we're definitely going to want to brush up on those to be able to be successful in the rest of this week. But not today yet. Today we're going to talk about some general angles and how we can graph angles for trig, and then what a radian is. So an angle has 2 sides we've learned in geometry, and those sides are rays. We're going to call one side the initial side or the starting side, and that's fixed. It doesn't move. And then the terminal side is a side that's going to rotate around. Terminal means ending. That word, terminal, means the end. So the terminal side is the ending side of the angle. And what we're going to imagine is kind of like a hinge. That initial side is fixed and it doesn't move, but that we can open up that hinge to create that angle, making the terminal side rotate around. When we graph angles for trig, we are going to do so always in what is called standard position. Standard position places the initial side on the positive x-axis. Always. It is always in that same location. The vertex will always be at the origin. And then we're going to draw out our angle with our terminal side being anywhere else around the circle.
It's kind of a weird question, but are the lights all always off? Because I feel like it's darker today. I think it's usually is.
Totally right question. Sometimes I do half and half.
Okay.
Today
I feel like it's darker.
Don't fall asleep.
It just
The shades are also closed from our code red. So don't fall asleep, but yeah, it is a little bit darker than usual. Alright, in the margin of your paper, I want you to doodle a few circles. Doesn't matter how many, doesn't matter how big, doesn't matter if they're perfect circles. Students always panic and start looking at each other's papers when I ask you to do this. This is not a test. Just doodle some circles. That's all I'm asking. Doodle some circles. As you are drawing those circles, now by a show of hands, how many of you draw a circle in a counterclockwise direction?
Yes.
Yes. It is a majority of people that do that. I don't know why. It's not a right-handed, left-handed thing. It's not like a right-brained, left-brained thing, like a science or art brain. It's just most people draw circles in a counterclockwise direction. I don't know why. But that will be helpful for the majority of people then, because when we graph an angle, we are going to measure it in a counterclockwise direction. So our angles are going to start at that positive x-axis and open in a counterclockwise direction.
What if you have an angle that's like that?
That doesn't work.
Doesn't work?
Nope. It's going to be like that. So our first type of problem for today is going to be to draw an angle. To do so, we're going to start with our x and y axis. Start with the initial side on the positive x-axis, always. And then the first question asks us to graph 210 degrees. We're going to go in a counterclockwise direction, 210 degrees. If I go around half of the circle, how far have I gone? 180. So if I need to go 210, how much more do I need to do?
30.
An additional 30 degrees.
So are we just like that?
Yep, we are not going to use a protractor, so it doesn't have to be perfect, but in graphing an angle, a few things are required. The x and y axis must be there. Your initial side needs to be on the positive x-axis. You need to have your ending side wherever it belongs. you need to have that little arc of a circle that shows which direction you drew the angle. And you need to have a measurement in there that says how large we intend that angle to be. Since we're not using a protractor and it's not perfect, we're going to put that 30 in there to show people this is how big we meant it to be. That number should always go next to the closest horizontal line. Some students want to put like a 60 in the lower section and say that at 210 is 60 degrees before we get to the 270. It's true, but for where we are going with this, it is not helpful. So we always need that number to be next to the closest horizontal line. For the next one, starting with the positive x-axis, always. That doesn't change for anything. But this problem says that we want to graph a negative 45 degrees. So something will change for graphing a negative. And that's the direction that we open up this hinge. So when we have a negative angle, instead of going around counterclockwise, we're going to go in the opposite direction and go around clockwise, 45 degrees. So again, we need the two sides of our angle. We need the arc of the circle that shows which direction we drew that angle in. And we need the measurement that says how big we intended that angle to be. That measurement of 45 does not need to be negative because it's just saying how big is it. The negative just denotes the direction, which is shown by that little arc.
That arc, can we draw like around the entire thing? Like, it would actually be between the two.
It should be just between the two. Because if it went around the entire thing, that would show that you drew it in a positive direction.
No.
Or drawing it in a negative.
I was just saying so that makes sense.
Oh yeah, I mean it can cover the full like width of the angle. Just needs to be inside of the angle. For the third one, start at the positive x-axis always. 510 degrees. How big is a circle?
360.
360. So I need to do a whole circle. And for this one, we're going in our counterclockwise direction, so it's a positive angle. So I've covered 360 so far, but I need to do 510, so I need to do more than that. How much more? How do I find that out? Subtraction. 510 minus 360. You can't just say like, well, I guess if you have Siri, but otherwise you can say like, calculator, how much more do I need to do? You need to know that we have to subtract them. So when I subtract that, I'm going to get 150 left to go. So that's going to take me to about here with 30 left over. Okay. Again, we always want that number that indicates how big the angle is to be next to the closest horizontal line, next to the closest x-axis. Yes?
So if it's above the x-axis, you're going to be doing what's remaining of the 90 degrees, but
Remaining of the 180.
well, the 180, but it's down below, then you would do
How much more?
how much more?
Yeah. Go ahead and graph out these three. For the first one, negative 120, I start at the positive x-axis always. Negative tells me that I go around clockwise, 120 degrees, which is going to be 60 degrees before the 180. Again, some students want to say that it's 30 past the 90 line, which is true, but not helpful for where we are heading in the lessons over the next couple days. We always want to take this measurement next to the closest horizontal line, so we want the 60 before the 180. For 400 degrees, we started our positive x-axis. We're going to go around counterclockwise, 360 degrees will cover a circle, and an additional 40 degrees to get us to 400. And for the final one, starting at the positive x-axis, 360 would be a circle, so I don't want to quite get there. I want to be just a little sliver of about 10 degrees before we get to that full circle. Questions on graphing angles?
Wait, I'm confused how you tell if the extra like 40 is 10 inches.
Next to the closest horizontal line. So a half of the circle is 180 degrees. So for the first one, 120 degrees stops 60 short of 180. So by a subtraction there. On the next one, my full circle covered 360, but I had to go 400. So I have to think about how much more do I need to do. 400 minus 360 gives me another 40 that I need to do. And on the last one, 360 would be my whole circle. 360 minus the 350 I want to do would leave 10 left over. And that
How
will
much
get
you have
left
left
over.
over or how much you have to go?
Well, it depends on where the angle lands. So the first one is how much left I had to go. But on the other two is how much more I needed to do. And it depends which side of that line it lands on. So sometimes we're subtracting in one way. Sometimes we're subtracting in the other way. If I draw an angle and I don't give a directional arc, so all I give is my initial side, my terminal side, and a number. You don't really know what angle I meant to draw because maybe I just wanted to do 40 and that was it. Maybe I wanted to go all the way around and then do 40, so that would be 400. Or maybe I wanted to go backwards, and that would have been negative 320. So you don't really know what I intended to do if all I do is give my starting side and my ending side.
Could you go around twice and then do 40?
I could go around 13 times and then do 40 if I wanted.
About
So you really have no idea what angle I intended to draw, but they all end in the same place. So these groups of angles that all end in the same place have a name. They are called coterminal angles. Co means together or with. Terminal means ending. So they are angles that end with each other or end in the same position. They happen once every circle because that line exists in that location, nowhere else. Okay? So a coterminal angle happens once per circle. I could be going around forward, I could be going around backwards, but I have to go around a whole circle to get back to that spot. How big is a circle?
360.
360 degrees. So to find coterminal angles, we are going to add and subtract 360 degrees to our value.
that's pretty.
In your homework, the directions are going to be just like this in the example that say we need to find one positive and one negative angle. So we're looking for two answers that match the original one. So like in the example I did above, if our starting angle was 40, we could add 360, would give us 400 as a matching positive, or subtract would give us negative 320 as a matching negative. So for the first example here, if I take negative 60 and add 360, that gives me 300. You don't have to graph them, but if you did graph negative 60 and positive 300, they would end in exactly the same place. Then I need a negative one. To get the negative one, I'm going to subtract. And that would give me negative 420. So if I graph negative 60, 300, and negative 420, they will all end in exactly the same place. It will just be that directional arc that's pointing in a different direction or spiraling around. You could, you said, in theory, add as many 360s as you wanted or subtract as many as you wanted. I'm going to ask that you don't, because when we go to grade the homework tomorrow, I'm going to give the closest possible answers, but you could add or subtract 22 360s if you wanted to. But please don't, because those are not going to be the solutions that are given in the homework. And when it comes around to the quiz on this, you're not going to be using a calculator, and I don't think you want to add 22 360s by hand. So let's just stay with our closest possible solutions. For the next one, that's a bad PowerPoint thing. That's supposed to be a bullet, not a negative 45. I think yours says B, so it's a little bit more clear on your paper, but that's just a 495. I could add 360 to this, and that is a totally fine solution. But if I subtract 360, I still get a positive solution. The directions want us to have one positive solution and one negative solution. So subtracting gave me still a positive answer. How do I get a negative answer? Subtract again.
Did you give the big one and then the really small one
Yes.
instead of 135?
Yep. So you could also give the one that is created by adding the 360, which would be 845. Did I add that right in my head? 855. So you could also give the positive 855 degrees, and that would be fine as well. But you need to give one positive answer and one negative answer, so you do have to go all the way to that negative 225.
So 135 works.
135 works, or 855, and also you need a negative solution. Okay. So make sure that you don't just add and subtract once and call those your two answers, because they might both be positive. So you need to go until you get one positive answer and one negative answer. Okay?
Will it ever be that you get 300? You're given 360, and it says to give you it wants you to give
Could be.
a positive and a negative.
Could be.
And 0 doesn't count as either.
0 is not positive or negative. So you go for it.
Okay.
So for this one, for negative 100, if I add 360, I get positive 260. If I take my negative 100 and subtract 360, I get negative 460. So if I would graph those two, and I don't have to because it doesn't say in the directions graph, but if I would graph those two and the original angle, they would all end in exactly the same spot. It would just be those directional arcs that were pointing different ways. For the second one, if I take 575, I could add 360 to it, get 935. That's a fine positive answer. But if I subtract 360, I get 215, which is still a positive answer. So I'm not done. I could give one of those two positive answers, it doesn't matter which one, but I need to subtract again to get a negative answer as well. So we add and subtract as many times as it takes until you get one positive solution and one negative solution.
We don't have to add. If we want to save time, we can just subtract.
Can you use the calculator?
You can for arithmetic purposes, yes. Our last topic for today is to talk about what a radian is. So we've heard this word once before. I think I mentioned when we started doing things on our calculator that we needed to make sure we were all in the correct mode, and we needed to be in degree mode. So some of you needed to go in and change because calculators, when they are purchased, are automatically programmed to be in radian mode. So we needed to switch this. A radian is another way of measuring an angle. So if I measure the length of something, like the length of the classroom, I could measure it in feet, in yards, in meters, in inches, in centimeters. I have a lot of options for measuring the length of the classroom. If I'm measuring a longer length, then I get more options like kilometers or miles. Those are all different ways to measure lengths. Angles have two different ways to measure them, basically. There's one other, but it's never used for anything. I don't even know what it's used for. So we have degrees, and we're pretty good with degrees. We've talked about degrees a lot. This year with 180 in a triangle or 360 in a circle, and so we've worked with degrees a lot. The other way is this thing called radians. So what a radian is, well, what does it sound like?
Radius.
Radius. Okay, so it comes from this circle. So what we're going to do is take a circle that has a radius of 1.
I give that circle
I have a tool that draws circles.
Angela's so simple.
I'm going to take a circle that has a radius of 1.
This is
And a radian is described by saying, let's take our angle that we were talking about, where we have our initial side here, and we're going to open up a hinge to make a terminal side. The radian says it is the way to measure the size of an angle by the arc of the circle it sweeps out. So the idea is, if I put like a pen or a marker at the end of the ray of that angle and opened it up, how much of the edge of the circle would it have traced out? Or like how much pizza crust is there? Okay? That's the idea of what a radian is. So if we're talking about the edge of a circle, what's the word we use for edge of circle?
Circumference.
Circumference. What's the formula for circumference?
It's like,
It involves pi.
Involves pi.
Isn't it 2 pi d?
Close.
2 pi.
2 pi r. We're going to talk about this again in chapter 11, so if you don't remember those formulas, that's fine. We'll get around to them in chapter 11. Circumference is the edge of a circle, and its formula is 2 pi r. So if we're working with an r of 1, then our circumference is 2 pi. So the way we are going to convert or switch back and forth between radians and degrees is by saying that 2 pi radians is equal to 360 degrees. Since those are both even, we're going to reduce this down to make it just pi is equal to 180 degrees. This is our conversion factor. It's the same thing as saying like there are 12 inches in 1 foot, or 2.54, I think, 2.58, 2.5 something centimeters in 1 inch. Okay, 5,280 feet in a mile. Okay, 3 feet in 1 yard. Okay, so for any time we want to move back and forth between units, we need to know how those two units are related to each other. This is the relationship between degrees and radians. That pi radians is the same thing as 180 degrees. So to do a conversion, we are going to multiply by a fraction of 180 and pi. We are always going to use 180 and pi as our fraction. To figure out which one's going to go on top and which one's going to go on bottom, we want to put onto the bottom the unit we're beginning with. So in the first example here, 110 degrees, we're beginning with degrees. We want to put the degrees onto the bottom of the fraction. You will always do a fraction of 180 and pi. You're going to put onto the bottom the unit that matches the original question. Because then they will cancel and we'll be left with the other one. So multiply this, we put together the tops there and the bottom. And then we want to reduce this. Don't type it in the calculator and get a really ugly number. We want it to be a fraction with pi in it, just reduced. So for the next one, negative pi over 9, we're going to use a fraction of 180 and pi. And we want to put onto the bottom what we started with, so it will cancel. So we're starting with pi's, we want to put pi on the bottom then, which puts 180 on the top. Because then the pi's cancel, and we get negative 180 degrees over 9, or negative 20 degrees.
Is anyone else hungry? All this stuff about pi.
I don't like pie.
For 320 degrees. Since it is beginning with degrees, I'm going to put degrees on the bottom, which puts pi on the top. Okay, you will always use 180 and pi, put the unit you are given on the bottom so that it cancels. Then that puts together the tops of these, the bottom all by itself, and then reduce. 320 and 180 both reduced by 10 would just cancel out the zeros. Then 32 and 18 are both even, so I can reduce them by 2 and I get 16 pi over 9. We want it as a fraction, but reduced. For the next one, negative 5 pi over 12 starts with a pi, so I'm going to put the pi on the bottom, which puts the 180 on top. The pi's cancel, and to do our arithmetic, we would do negative 5 times 180 on the top and divide by 12 on the bottom. So you can use a calculator on this, and I would do negative 5 times 180 and divide that by 12, and we end up with negative 75 degrees. Questions on converting? I have a couple of more examples in my notes that you don't have in yours, because what we need to do is go back and look at our first couple types of problems, thinking about radians now. So first, how to draw an angle in radians. So you will want to take notes on this because you do have problems like this in your assignment. When I draw an angle in radians, what we're going to do is still graph it. I usually don't draw my y-axis though, and I'll show you why in this problem. The bottom of the circle tells us how many pieces to cut each half into. Because on the top of the fraction there's a pi, and a pi is equal to 180, or half of a circle, and we are dividing that pi, or 180, by 7. So we are dividing half of a circle, or 180, into 7 pieces. So I'm going to cut the top half of this circle into 7 pieces, approximately equal, as good as you can. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay. Mine are not very equal, but you just kind of sketch it. Okay. Doesn't have to be perfect, but I'm cutting the top of that circle into 7 pieces. That's why I don't draw my y-axis, because whenever we're cutting into an odd number of pieces, that y-axis is just going to get in the way. The top tells you how many pieces to go. So we still start out here straight to the right at our positive x-axis, and the top tells me that I want to go 3 of these pieces. So my angle ends right here. Okay. The bottom tells you how many pieces to cut each half into. The top tells you how many pieces to go. For negative 3 pi, that's like over 1. So I'm going to cut each half into 1 piece. Well, that's already done. Right? Just my x-axis cuts each half into 1 piece. Now I want to go negative 3 pieces. So I'm going to start at my positive x-axis. Negative tells me go backwards 3 pieces. 1 piece would be the bottom. 2 pieces would be the top. 3 pieces would be the bottom again. And that's how our angle ends up. Okay?
So 180 degree angle.
Yep.
Can you draw it? Does the second bar always have to be on the outside of it? Or could you do it inside?
I usually spiral out because sometimes I just don't know how many spirals I'm going to have to do, but you could spiral in.
Whenever it's over 1, is it, if it's an odd number, is it going to be 1 and 180?
Wouldn't it be the same for positive too?
Yep.
Always 180.
If it's over 1 and an odd top. Yes. Now we're going to talk about coterminal. Nope, we're all right. Okay. Coterminal. When we found coterminals in degrees, what did we do? Added or subtracted 360. 360 is a whole circle in degrees. So if I'm working in radians, what is a whole circle? 2 pi. So we are going to add and subtract 2 pi to our value, because 2 pi is a whole circle in radians. So for this problem, I have 19 pi over 3, and I want to add or subtract 2 pi. I'm going to start by subtracting and just see where that gets me, and then decide if I need to add. I need a common denominator to be able to add fractions or subtract them. So I need a denominator of 3. So 2 pi becomes what over 3? 6 pi over 3. 6 over 3 is equal to 2. We need a common denominator to be able to add or subtract fractions. Because 6 divided by 3 is the same thing as 2. We want to add or subtract 2 pi, but we need it to have a bottom of 3. So 6 over 3 is the same as 2. So when I subtract these then, I get now 13 pi over 3. That's still positive. So then I would need to subtract again. 7 pi over 3. Well, that's still positive. Subtract again. Pi over 3. Well, that's still positive. Subtract again. Negative 5 pi over 3. And I finally got to a negative answer. And any one of the positive answers would be an okay positive answer. Okay. Add or subtract as many times as it takes to get a positive and a negative answer. When we're working in degrees, we add and subtract 360 because 360 is a circle of degrees. When we're working in radians, we are going to add and subtract 2 pi because 2 pi is a circle of radians.
Do we get marked down if we don't show our work?
No. Questions? Your homework is a worksheet in the packet. Please don't do your homework on the sheet because then you'll need to rip it out and that will have your notes there for the next day. So just go ahead and do it on a regular sheet of paper, but you don't need to bring your textbook home to do that homework worksheet tonight.